Hello all, today in this video I'm going to work with heart disease prediction with ANN, that is autoencoder. So from scratch itself. So previously and with as a continuation of the video, we will be working with the other deep learning algorithms, and the data set we downloaded from Kaggle. You can just give us a heart disease prediction. Kaggle means you can just get you will get that data set. So first we have imported the libraries which we have needed. Then we are calling our dataset. This dataset we downloaded from Kaggle. This dataset is having nearly 14 entries, and we are getting the data. So it is having nearly 14 entries, and all its data types are integer and one is float. Then we are describing our dataset, and then we are checking our dataset is having any null values. If it is having any null values means we have to work with some pre-processing functions. Then we are getting the heat map of the data set. So this is the heat map of the data set which we have downloaded from Kaggle. Then we are determining the x variable and y variable. Previously we saw that our data set is having nearly 14 entries. Among that, the first 13 entries we will be using as the x variable. So the last entries we are just dropping, and the first 13 we are using as the x variable, and the last variable is used as the y variable. Then we are using the 80-20 rule, that is 20% for testing and remaining 80% for training. By using that, and also by use of the train test split function, we are determining variables like x train, x test, y train and y test. And with the x variables we are working with standard scalar, which just scales or work, that is it just converts the vectors. And then we are working with the scalar function. So we are getting the shape of the data set. Why? Because in autoencoder the input will be took as this shape only. So we are getting the shape of the data set, which is 820 comma 13. Then we are getting the shape of the y train function, and y train also, which is the same 820, but we are not going to use the y train shape. We are going to use the x train only. Then we are making the classifier. So first if we are using an initial sequential layer. Then we call the dense layer with the output dimension as level 11, and the input dimension is this 13. And we have given the initializer as uniform and activation as ReLU. Then again we are calling a dense layer with output dimension as 11, initializer as uniform and activation as ReLU. Then the last dense layer with the output dimension as 1. Since why this data set is having only two classes like 0 and 1, and our data is an binary classification work only, so the output dimension is 1. If you are using some multi-class classification means it will like be 3 4 based on the number of classes it will change. But here if it is a binary classification means the output dimension will be 1 only. Here we are using the activation as sigmoid. Then we are using the compile function. For that we are using the optimizer as Adam, the loss as binary cross entropy, metrics as accuracy. So then we are just again by mistake the compiler function is given by mistake. Here we are getting the summary. You can notice that the output shape and the parameters for everything is given. Then we are using early stopping also by the patience of 3. If so means for 3 approaches, if the value of the accuracy and loss is not showing very much big difference means, in that case early stopping will just make its operation, and the approaches will stop at whatever point. Maybe if approaches is in first 3 approaches, if it is not showing not much difference means it will just stop. For that only we will be using early stopping. Then we are training our function by classifier by using the fit function with the variables x train, y train, and we are also using the validation data like x test and y test, and we are training for 50 approaches. And also we are using early stopping. Here our work is done for 50 approaches. Since I think it is not showing much difference in every approaches, since it is changing for every approaches, early stopping has not made that operation. So for 50 approaches we have got the loss accuracy and validation loss and validation accuracy. Then you can notice that we are making a plot by using the accuracy, validation accuracy, loss and validation loss, by using some title also we have given. So for a better model, other than the training accuracy, validation accuracy should be higher. So here you can notice that other than the training accuracy, validation accuracy is only high. And also once the training accuracy is high, obviously training loss will be low. This shows that ANN is a better model. And we have also got an accuracy of 91%. Then we are plotting the confusion matrix by creating a confusion matrix definition. Here you can notice this is the confusion matrix for the autoencoder. In the next work, we will be working with some other optimizer. Here we have worked with Adam, right? So in the next work, we will be working with some other optimizer. Thank you.